Now we're going to apply our sig fig rules along with our dimensional analysis knowledge as well. So in this example, it tells me that I want to convert a certain number of meters to kilometers. And let me just point something out here. This is meters. The abbreviation for miles, if it's abbreviated, is MI. Okay, so just a little heads up for you. And then there's another M, capital M, and oh good, I can move back here. A capital M would be mega. So it's a different prefix on the metric system, okay? So we're down here, not milli, okay. Like if it was millimeter, then you would see M and M. And that's not what we're looking at. It's just meters. Okay, so what we do here is, one thing we have to figure out, and I'll just say this, there are oftentimes multiple ways that this can be described, can be approached, and this is one way. And like for example, one thing that I'm always aware of is what set of units do I have to go through, or sometimes I call it my path. Okay, and this one, what's going to happen is I'm going to be able to go from meters directly to kilometers. How do I know that there's just a single step in this calculation? Well, one thing, both of these units are units of length, so that's useful, and both of them are metric units. Meters and kilometers are associated with the metric system. And oftentimes, like if you're going from, I'm thinking of a density calculation, mass to volume, and then there's also a change in the volume unit, then like each step there I described includes at least one conversion factor in your calculation. But if you're dealing with the same type of measurement, length, and you're sticking within a given measurement system, unit system, like the metric system, then it's usually just one step. Just as a hypothetical, okay, if it was like, let's say, meters to inches. Sometimes when you look at the conversion tables, you see a single conversion factor for this. Sometimes it's not listed. But oftentimes when you're going from metric to English system or back and forth, there's an additional conversion factor that's needed. All right. Anyway, let's get to the problem at hand. What is our conversion factor? Well, when you're trying to work with the metric system here, and we're working with kilo on this one, right? So that means, and usually don't use this notation, usually using this notation. And then, you know, the meter or whatever base unit you're dealing with would be right there. Right, that's like right in the middle. It's the one, okay? There is no exponent associated with that one. The exponent comes from, you know, going 1, 2, 3 up to kilometer. Okay, and again, the little k stands for this particular symbol. That's an important reference point here. Like for example, to determine the conversion factor of anything, any, you know, one metric unit to another metric unit, what you can do is say something like, well, if I had 1 kilometer, and usually it's always in reference to the unit with the actual prefix, how many, may need a little more room, how many meters is associated with that value? And what you do, or what I do, and I sent out an email a little bit about this yesterday. You know, what you're after is an expression where you're basically using that abbreviation and the exponent together there. Sort of like the 10 to the 3 is a stand-in for the little k. Or just to do another one, let's say it was, I don't want to do a microgram. Let's say you have 0.2 micrograms and you want to convert it to grams. And you need a conversion factor between micrograms and then, you know, whatever the base unit is in that spot. The difference of 10 to the minus 6. So what would that look like? Again, you'd say, well, what is 1 microgram? Start with a prefix, and then basically in place of the prefix, just put the exponent that's sitting there. And that establishes a conversion factor you would use for this calculation. Just like I have established now the conversion factor that I use for this calculation. Dimensional analysis. It's the same like logical pattern each time you do this. You start with the data that's given to you, okay? And again, you're going there. So 5,678 meters. And I want to convert that. I want to calculate the number of kilometers here. And what that means is that, okay, so dimensional analysis, the way you handle this is that whatever unit you're starting with, it's that portion of the conversion factor that's going to go on the bottom of the set of parentheses here. And then whatever is left, that guy is going to go on top. So I think of the dimensional analysis form here is like a mathematical template. Tells you what you need to multiply by, what do I need to divide by. So anything that's on top, you're going to multiply by. Anything on the bottom, you're going to divide by. So numerically on the calculator, you're going to take that and divide by this number. And then what happens is that the meters cancel out here and you're only left with kilometers, okay? And then the math, well, basically what you're doing when you divide, this is 1,000, it's going to move the decimal over 3 places. And so your answer is going to be 5.678 kilometers. Now, this is one of those examples where there's like multiple steps that you have to go through. Like, for example, the heart of this problem is right here. What it's asking you to do is to convert 15 kilometers to the number of laps on this track. But notice that the unit that's given for the track is not the number of kilometers per lap, but you're given feet per lap. So this is a little bit more challenging problem. So again, focus on this. You got this distance and we want to go to the number of laps. This is our goal. How do we do this? Well, look for, is there a relationship? Is there a conversion factor in the problem that connects the number of laps directly with kilometers? The answer is no. What you have to do first is, this isn't possible. What you have to do first is go from kilometers to miles, and then from miles to feet. And now we can go from feet to laps, okay? So 1, 2, 3 steps, 1, 2, 3 conversion factors. Now, Tro's giving you one, you can look up the other one, and the one that I have, it says that 1 kilometer equals 0.62137 miles. So notice what's happening. You're using this first conversion factor to go from the metric system into English system, empirical system. There's a couple of phrases for it. And then once you're in that environment, then I can use the miles and feet here to then do the next conversion. It's really converting that distance, that long distance to the shorter distance. But I use the same logic, right? What unit do I have here? I have miles. And so that portion of the conversion factor is going to go on the bottom. And then the other portion is there. And just let me pause for a second. You know, if I went through a couple steps here, any unit that's on top and bottom, you cancel out in the expression. That is why dimensional analysis works so well. It gives you sort of a visual cue in terms of your unit cancellation as well as your mathematical operation, which we'll do at the end of all this. And then miles and miles also cancel out. So if I went through the math up to this point, I'd have the number of feet that's equivalent to 15 kilometers. Now, I don't want to stop there. I got to go one more step, laps. Well, this particular expression, you know, what this is saying is that one lap is equal to that 1,056 feet. Well, it's just another conversion factor, and I handle it the same way. Whatever unit I have here, that's the unit that's going to go on the bottom. And by the way, my computer is being taxed. So that's one reason why you see the little errors here and there. Now I'm ready to do my math, right? Because feet and feet cancel out, and now I'm left with laps, which is what I want. So mathematically, what you're doing here now is you are taking same rules. Whatever numerical value is on top, you're going to multiply by. Whatever numerical value is on bottom, you're going to divide by. Now, of course, the first two, divide by one, right? Numerically, that doesn't do anything. It's just reminding you of that is what that means. I mean, you are dividing by one, but again, it doesn't affect it numerically. Multiply by this, multiply by that, and then you'll divide by the 1,056, and that will give you your proper answer. And let's go ahead and round off 3 sig figs. You know, whenever you're dealing with these types of calculations, typically I say, and this works out, there's like 1 or 2 examples where this doesn't work out, but you don't have to worry about it. You, boy, yeah, my computer's really working hard here. You ignore the sig figs for your conversion factor. You just use your data here. So 3 sig figs, when I plug and chug this, it gives like 46.60 and some other numbers. And so 3 sig figs, 46.6. Now,